Hi guys, welcome again to my channel. My name is Malasa, and today I'm gonna be show you the detailed slab design of this 20-story building using etabs 2016 as per the Ethiopian and European building code of standard. In the previous tutorial, I have already shown you the design principles that we need to follow while designing slabs. If you are a new member for this channel, so don't forget subscribe my channel. If you subscribe my channel, you will be getting more relevant tutorials which have already been prepared with reference to the structural analysis and designing of this 20-story building using ETABS 2016 as per the European and Ethiopian building code of standard. If you are also a member of my channel, don't forget sharing all my videos to your friends so that your friends will be getting more relevant tutorials which have already been prepared. If you want to get also an immediate notification for the newly uploaded videos, you can press the bell icon. And if you have any questions regarding to the structural design of any civil engineering projects, so don't hesitate to provide me comments and questions in my commenting box so that I will be trying to give you a response within a short period of time. Now let's proceed to the today's tutorial, which is tutorial part 25, which will be focusing on the detailed designing of the slabs of this 20-story building. So before proceeding to the detailed designing of the slabs of this 20-story building, now let me tell you how you can find me in YouTube. In order to just get me in YouTube, simply you can write global structural design and construction solution in your browsers. That means global structural design and construction solution here. And just you can see global structure design and construction solution as a headline of the browser. Then you can just click this one. So here there are lots of structural design tutorials prepared for reinforced concrete and steel structures. Here just you can see the different tutorials which were prepared starting from the modeling parts of the reinforced concrete structure and steel structure up to the design parts of the structures. You can just select the what you like here. Lots of tutorials are uploaded, and I have also the structural analysis and designing of steel warehouse here and steel connections here as per the Ethiopian building code of standard and European building code of standard, and even just you can get more tutorials that were prepared with reference to the reservoir. Just you can visit my channel in order to get more relevant tutorials with reference to any civil engineering projects. Now let me proceed to the today's tutorial, which is the tutorial part 25, which will be focusing on the designing of slab. So here now let me this is the model that I have already modeled and analyzed 20-story building. Here just we have the load combinations here. That is the load combinations comprised of the permanent load and the variable load, the notional load, and the dynamic load, such as the linear static load and the response spectrum loads. So here I have already finished the definition of the logic combinations. Now let me run the analysis prior to exporting the slab results to CSI SAFE. Now let me run it. Here now etabs is analyzing this journey story building based on the provided logic pattern and logic combinations, which incorporate the variable load, the permanent load, and the imperfection load, and the linear static load, that means the RZQ load, and the response spectrum load. So all those loads were combined together in the previous tutorial. So using all those combinations and load cases, ETABS will extract the maximum and the governing load for the designing of the structure. So here it is taking more time because we have more load combinations and more load cases. Here now it is almost on the way of completion. Now here the analysis is completed. So now let me check whether the design of frames are adequate or not. Now just to do this, go to the frame design button here and here select the design combinations. Sorry, you just go to the here, that is view the frame design preference to Eurocode 2 2004. Just be sure that the Eurocode 2 2004 is selected here and just take all the rest parameters as it is. Now click OK. And we need to also select the design combinations. And here all the design combinations are here selected. So incorporating all the loads, because all those are the load cases. So load cases will not be transferred to the design load combination because design combinations will use the combined loads. Now click OK. And then just start the designing of the frames. So we have to be sure that all the frames are passing the design. If they are not passing the design, we need to revise our sections. If all the design sections are adequate, then we can export all the floor forces to CSI SAFE for the designing of slab. So this design incorporates all the design combinations that we have defined before now. Let me check whether all the sections passed or not. Now to do this, that is verify all members passed. Here, concrete frame passed the design check. So now our frame design is okay. So what we are going to do, just we need to design the major portion of this 20-story building, that is a slab. So in order to design a slab, I need to use CSI SAFE. So before just go to the CSI SAFE, I need to export these results which I'm going to use for the designing of the slab to CSI SAFE. So now go to the file menu here and then just go to the export menu here, and now I need to export the results to the CSI SAFE. And here I need to select the story that I'm going to design using CSI SAFE. So here I have to select the second slab, that is the second floor slab. So here I have options, that is loaded to export. So which load will be exported to CSI SAFE? So export, here we have three options. Here we have three options. Is export floor loads only, and export floor loads and loads from above, and export floor loads plus columns and wall distortion. Here we have three options. So basically for the design of suspended slab, we can use this option. And for foundation, we can use this one. This is for foundation, because the designing of foundation uh, uses the loads coming above the floor. The third one is export floor loads plus column and wall distortion can be used for the designing of foundations when there is a temperature load here. There is a temperature load, meaning which result in distortion of wall and column. So for the time being, I need to export floor loads only. So now, and the other, I need to select the load cases here. I need to select all the load cases. So 47 of 47 load cases are selected here. And I need to select also all the load combinations, because I will be using all the load combination for the analysis and designing of the slab. So after that, I need to click OK. And here I need to provide the file name here. So make it 2 and save it. So go to CSI SAFE and go to the file menu and import the F2K text file. So etabs will direct me to the exported F2K file. Here, where is it? F2K file one, and this one here. And now open it. And here, CSI SAFE theory is exporting the results of the slab exported from the etabs. Here, just I can close this one, or just I can make as it is. So here, this is the slab and the slab output exported from etabs 2016. So I have to be sure that all the loads are exported to the CSI SAFE format. So to do this, I need to go to the display menu here, show load assign. That is, first I need to check the shear load or the frame load, and anyway I need to check the shear load. Here, this is the self weight of the structure. Now let me check the wall load and apply it. Here, the wall loads are displayed. So here the wall loads are exported properly. And now let me check also the water tanker load. Here I don't have any water tanker load on the second floor slab. And here I need to check also the waterproofing load, right? I don't have it. RZQ load, that is RZQ X plus here. Because you know this RZQ X plus load is not applied on the floor slab. Instead, those loads are applied on the frames. And now superimposed load that is applied here. The superimposed loads are exported from the etabs properly. And now let me check it the live load for roof, and here okay. Now let me the notional dead load in x positive direction here. So let me check it. Okay, I don't have any notional load because notional loads are applied as a lateral load. So all the gravity and variable load will be displayed on this slab. So in the case of response spectrum also, I don't have just a load. But you know, the 50% of the lateral load will be incorporated for the designing of this slab. Here, okay. Okay, now let me define the strips both in x and in y direction. So as we have already seen in tutorial part 24, we need to define the column strip and the middle strip both in x and in y direction. So for the simplicity of the analysis and for the interpretation of the analysis results, that is better to provide 1 meter strip width for both column strips and for middle strips. So to do this, I need to go to the define menu, I mean the edit menu. Then here just I can use add the design strip method. Here I can use this one, or just I can go to the draw menu here and just go to the draw design strip option here. So here I need to define the strip width, that is 1 meter, or that is 500 millimeter for simplicity interpretation of results. 500, and here it is 500, and here it is what it is 500. So first I need to define strips along in x direction, that is the strip layer is denoted by A, and the strip design type is it is a design strip. Now first I need to define the column strip along in x direction. So here I need to define the column strip here and the column strip here. I will delete later, and the column strip here, column strip here, which connects the center line of the column. Here, here. And now I have finished defining the column strip along in x direction. So I need to define also the middle strip along the in x direction. So here I need to make it middle strip. Just go to the snap option. So I need to make it the snap on for midpoint. So this is the middle strip, and this one is the middle strip, and this one is also the middle strip, and this one is also the middle strip, and this one is also the middle strip. Okay, I have finished defining the middle strip along x direction. So I need to define also the column strip along y direction. So to do this, I need to make this the strip layer B for y direction, and I need to make it the column strip, and the size of the strips are similar to the strips defined in x direction. So here I need to draw the column strip here, column strip here. So we need to keep the center line of the columns. And here I need to connect the center line of the columns here. Actually, the center line of this column is not connected with the strip, but roughly it is accounted as the column strip. And now let me define the middle strip in y direction. And I need to define also the column strip along uh, in y direction, which is closer to the shear wall. And I need to define also the column strip along x direction for the shear walls. I think this draw. Okay, this is already included here in this strip, and this one is drawn. And here all the column and the middle strips are defined properly. So I need to delete this one because I don't need it. Okay. So here I have a column strip here, uh, and I have a middle strip here. So here the definition of the column and the middle strips is completed. So I need to run the analysis. So before just running the analysis, I need to check the option for the crack analysis. That is go to the analysis menu here and the crack analysis option. So I need to use the user-defined rebar or designed slab rebar, or just I can use this method. So whatever you like, you can use it. But I can use the design slab rebar method because CSI SAFE will take the area of reinforcement, which is provided by the CSI SAFE for the checking of crack analysis. Now click OK. So after that, just go to the analysis menu, and here just run the analysis and design. So before just proceed to the designing of the slab, that is better to check the codal preference. Here now the analysis is completed. Here we need to check the requirements of serviceability, such as the deflections. So we will have a separate video on deflection of slabs with reference to the Ethiopian Building Code of Standard. So for the sake of just knowledge, we can check it here in just in order to check the deflection. Okay, here go to the option, show gross error. Let's select all. And click OK. Okay. So here I need to check the deflection for the service load here, and now click apply. Now here this is the deflection of the slab for gravity loads. So here just we can see it, that is the maximum is 0.12 millimeter and the minimum is minus 8.211. The Ethiopian Building Code of Standard and the European Building Code of Standard limits the maximum allowable deflection, that is the 8 over 250. This is for what? This is for the normal combination. This is for normal combination. That means for a situation where there is no any seismic action. But whenever there is a seismic action for quasi-permanent load combination, the deflection is L over this 500. So where L is, it is the in the case of flat slab, this is the shorter, I mean the longer span. This is the longer span. So the longer span is this one. Here, starting from here up to here, which is nearly 8 meters. So that is 8,000 divided by this 500. How much is it? This by this 80 by 50. 80 by 50, 1, 5. So that is here it is 60 millimeters. So the allowable deflection, that is the allowable deflection delta. Allowable deflection is how much? It is what? It is 16 millimeter. And the actual is, this one. That is minus 8.211. So the actual deflection of our slab is less than the allowable deflection limits specified in Ethiopian Building Code of Standard or in European Building Code of Standard. So this concludes that the thickness of the flat slab, which is provided during modeling, is adequate enough to withstand the superimposed loads and the seismic loads. Okay. So now let me proceed to the designing part. So here, in order to design the slab, I can, as I have already told you, that we can use strip method or we can use the finite element method. Okay, now prior to the design works of this flat slab, now let me first define the codal parameters. So that is the codal preference. So in order to define the codal preference of the Ethiopian Building Code of Standard, yes, we can use the European Code of Standard in order to design this flat slab. So to do this, just go to the design menu here and then go to the concrete slab or beam design button. Then view revise preference. Now click this one. And here, just I need to select from the drop-down list the Eurocode 2004, which is similar to the Ethiopian Building Code of Standard. And then just go to the this dialog box. Here, all those parameters are defined as per the Ethiopian Building Code of Standard and the European Building Code of Standard. So here the country is the here CEN, that is the European norm default is selected as it is, and the logic combination is that is equation 6.1, which is the governing logic combination is selected by the code. So we may have 6.2 and 6.1. Here we have three logic combination sets. That is here just 6.1, 6.1a, 6.1b. But for the time being, we need to select the governing logic combination, which is 6.1. If we select this logic combination, so will not be economical. Will not be safe as 6.1. So the software will take by default the safe and the governing logic combination, which is 6.1. And the reliability class is that is class 2 is selected by default, and the data, which is corresponding to the imperfection logic combination, that is taken as it is, watch 0.005, and the gamma still, all the races are taken as it is. So, and now we have to also define the cover here. The top cover is 50. So it is the default which is taken, which is provided by the code. So we can take 20, this one, or just we can take this 20, or just we can take as it is, that is 15. Just you can change as you like. And the preferred diameter is 18, or just you can make that is 16 for the negative reinforcement, and for the positive, that is the lower diameter can be used. And the inner slab river layer is, that is layer B, which is along the y direction. This becomes the lower one. And the post stationing, we don't have any post stationing here. Then the tendon bar. So we can take the rest as it is here. Just we can select the slab type, because we may have one-way slab or we may have two-way slab, but most of the slabs are there two-way slab. So we need to select two-way slab. So and then just click OK. So before that, now let me, that is view reference here. Just I have finished defining the cover related issue, and the minimum cover for the beam, it is not necessary here. The tendon structure, it is not necessary. So just the only task that we need to modify is the minimum cover for slab and the factors. Now click OK. So here I have finished defining the codal preference and the slab covers. Now let me proceed to the design dot combination setup. So to do this, just go to this one, and here select the design load combination. Here we have, previously all those loads are just coming to this one. So we need to select all those loads. Then we need to transfer to the design combination. And similarly, we need to transfer this one. So the only load combinations that should not be transferred to the design load combination is the load cases. So now click OK. go to again to the design menu here, and now start the design check. Now CSI SAFE is designing the slab. Okay, now let me detail the reinforcement works of this flat slab using the design strip method. So here I have already designed the slab using CSI 2021. So now let me show the slab design. So to do this, you just go to the display menu. Then here click the show slab design button here. Now here we have two methods, the strip based method and the finite element uh, based method. So I'm going to use the strip method. So here I have two direction, that is direction X and direction Y. Direction X is it is layer A, and direction Y is it is layer B. Now for simplicity of detailing, now let me first select the layer B. So here I'm going to use the show rebar intensity, that is area per unit width. So our width is it is 1 meter. So the reinforcement area per unit per 1 meter width of the design strip will be displayed. So here now let me make all the rest as it is. Now click apply. So here the reinforcement area per unit meter width of the strips are displayed. So now here the area is that is now let me first detail the negative reinforcement, that is the top reinforcement at the supporters of the column strip. Here this is the column strip, this is the middle strip, and this is the column strip, and it continues like this. So now 1190 1195. So here taking the maximum reinforcement area per unit width of the strip at this support, it is around 1195. So now let me go to the spreadsheet. Here that is 1195. So here diameter 60. Yeah. We can use the table below the read uh, color details. So I can use a diameter 11 with a spacing of 150, or I can use diameter 12 with a spacing of 75. But 75 it is to be congested, so I can use diameter 60 with a spacing of 150. Now let me go to the AutoCAD file. So here I can make it diameter 60 at a spacing of 150. So just like this. This is the column strip. Here, uh, the the strip width is starting from here up to here. We designate as it is a column strip. So now let me go to axis 2. Go to the safe model. Now here I have 84.75. So this is what? This is the maximum of this the maximum reinforcement area per unit width of the strip at this support. So that is 85. Make it 85. So how much is it? It is diameter 60 with a spacing of what? How much is it? It is 11. I mean it is 100 millimeter spacing of diameter 16 reinforcement bar will be placed at the supports of the column and strip located on the axis 2. That is uh, with a spacing of what? It is 100. Just go to the AutoCAD file, then click this one. So make it is what? 100. Just like this. And go down on axis 3 on the third support. That is the third support is this one. How much is it? It is around 21, 29. 21, 29. Make it 21. Okay, sorry. This 21, 29. 21, 29. So diameter 60 with a spacing of 75. Diameter 60 with 75. I can keep as it is. Then on the axis pole, it is around 23, 23, 50. I mean 23, 60. How much is it? This with a spacing of 75. So diameter 60 with a spacing of it is 75. So I have finished detailing the negative reinforcements of this column and the strips. Now let me go to the bottom reinforcement. That is the positive reinforcement at this column and the strip. First, detail the positive reinforcements of this column and the strip. This one. So I can take the maximum 634. This is the maximum of the positive reinforcement. That is 634. 634. So diameter 12 with a spacing of 646. Or I can take the diameter 40, 634. That is 634. So when I use diameter 40, that is diameter 14, it is around what? 225. So when I use diameter 12 with a spacing of 175. Now let me check on this spreadsheet also diameter 12 at a spacing of 175. Now let me go to the cut. That is diameter 12 at a spacing of 175. Diameter 12 at a spacing of 175. It is already provided. Here, diameter 12 at a spacing of 175. Diameter 12 at a spacing of 175. Now I have finished providing the positive reinforcement for this column strips. Now let me go to the middle strip. So first, now let me detail the negative reinforcement. Just go to here, negative reinforcement. So here 1094. 1094. 1095. So diameter 60 with a spacing of 175. Here, diameter 60 with a spacing of 175. This one. And now the second support here. Just come to here. It is 460. 460 negative reinforcement. 460. So diameter 12 with a spacing of 250. Now let me check once again. 150. Now the third supports of the middle strip. It is 460. So more or less they are the same. It is 547. Now let me check. Let me take the maximum of this 514. So diameter 12 with a spacing of 200. So I can take with 200 spacing. So I can make all 200. I can make this 200 because they are nearly equal. So take this one, it is 200 with diameter of 12. And this one also 200 with a spacing of with diameter of how much is it? It is 12. And this one also the same. Now let me check it once. Here we don't have any negative reinforcement. 1, 2, 3, 4. So we need to provide at 4 supports. So I can take similar reinforcement detailing here also. That is diameter 12 with a spacing of 200. Okay. Now I have finished detailing the negative reinforcements of this middle strip. So now let me go to the positive reinforcements of this middle strip. Now go to the CSI SAFE. Then take the maximum of the positive reinforcement from this middle strip. Which one is the maximum? 765 is the maximum. 765 because I need to take the same reinforcement diameter and the same reinforcement spacing for the easiness of the workmanship. I need to lay 1 verga or 12 meter span of reinforcement at the bottom portion of this middle strips in order to save time and cost. That is, so the reinforcement is this 765. 765. So how much is it? It is diameter 12 with a spacing of 125. That is diameter 12 with a spacing of 125 is provided as a positive reinforcement for this middle strips. Now let me go to this the second column and strip here. That means this one. So here now let me detail the reinforcement of this support. That is 2300 what? How much? 2330. 2383. That is 2383. 2383. So I can use diameter 60 with a spacing of 75. That is diameter 60 with a spacing of 75 here. And the second support, this one, also here, this one, this 2598. 2598. 2598. How much is it? That is diameter 60 with a spacing of 75, which is the same. That is diameter 60, 75. The third support of this column strip. Just go down here. That is 1397. That is 1397. 1397. How much is it? Diameter 60 with a spacing of 125. So this spacing becomes 125. And the fourth support, this one, that is 20, 30. That is 20, 30. How much is it? The diameter 60 with a spacing of 75. That is diameter 60 with a spacing of 75, which is already provided. And the last support, which is at the edge, just go down here. That is the fifth support here at this point. So it is around 70, 45. It is 17, 45. How much is it? Diameter 60 with a spacing of 100. So I need to make it modify explode. It is 100, diameter 60. This is the detailing of the negative reinforcement for this column strip. And now let me detail the positive reinforcement. So I can take the maximum one. That is 742. And here, so the above one is, it is the maximum one, 742. 742. How much is it? Diameter 12 with a spacing of 150. Here, diameter 12 with a spacing of 150 throughout the span of the bottom, at the bottom portion of this column strip. Okay, now let me design also the second middle strip, this one. Which is this one. So first, now let me detail the negative reinforcement, that is 460. 460. That is diameter 12 with a spacing of how much? It is 250. But I can take that is 200. Diameter 12 with a spacing of 200. 200. At the second support of this middle strip. Here it is 460. Almost it is the same. Here at this portion also 631. So more or less they are closer. 631. So 844. It is 1057. Here 1057. So I can take the maximum of that is 844, which is closely equals to this one. So the rest, the three support here, it is around, how much is it? It is 464. 464 is the same. So that is, this one becomes, that is diameter 12 with a spacing of what? It is 200, which is the same. Here at this support, now let me check it once. Here, that is 630, 600, 640. So 640. So diameter 12 at a spacing of 175 is adequate. So here it is diameter 12, 100, diameter 12, 175. This one. So go down here at this support. It is 722. It is 722. So diameter 12, 150. Diameter 12, 100. This diameter 12, 150. This one. And here also, that is, it is around here. It is 460. That is diameter 12 with spacing of 200. This one. That is diameter 12 with a spacing of 200. And similarly here also, this is the column strip portion. Now I am detailing the middle strip portion. And this one also here, just go to down, that is 800, 844. That is 844. Now diameter 16 with a spacing of what? I mean diameter 12 with a spacing of 125. It is 125, sorry. So the last support is this one with a spacing of 200. This is 12 with a spacing of 200. So the last support is here. Okay. And here, that is 1057. Is 70 45. So diameter 60 with spacing of 100. It is diameter 60 with a spacing of 100. So I have finished detailing the negative reinforcements of this middle strips. Now let me go to the bottom reinforcement. So in order to detail the bottom reinforcement, I need to take the maximum of the positive reinforcement. Okay, this one is, it is 1057, sorry. I have taken wrongly this one, 1057. This one, diameter 16 with 175. This one, 175. So now let me go to the middle strips. The bottom reinforcements of the second middle strip. Okay, I can take the maximum of the positive reinforcement. That is 573. 573. Okay, the maximum is 577. 577. So the bottom one is, it is diameter 12 with a spacing of 175. Here, diameter 12, 175 is provided throughout the span of the second middle strip as a positive reinforcement. So now let me go to the third column strip here. So here the reinforcement area is 31, 37. That is 31, 37. How much is it? Diameter 20 with a spacing of 100. This one, diameter 20 with a spacing of 100 is provided here. Now the second support here, it is 3401. That is 3401. How much is it? Diameter 20 with a spacing of 75. Diameter 20 with a spacing of, this one is, it is 75. Now the third support here, I think this one is, this support, the negative reinforcement at this location governs this support, so I can use the same reinforcement area. Okay, now just go down. Here it is 1276. Now it is 1276. How much is it? Diameter 16 with 150 center spacing. This one. That is diameter 60, 150. Here, diameter 150. That is diameter 60. Just go down, and at this support, it is 1590. That is 1590. So diameter 60 with a spacing of 125, or diameter 20 with a spacing of 175. So I can use diameter 60. or I can use diameter 20 actually. I can use diameter 20 with a spacing of 175. 175 here. And the last support, hit this one. It is around 1381. 1381. How much is it? This is diameter 60 with a spacing of 125. That is diameter 60 with a spacing of 175. So up to this point. So I have finished the negative reinforcement detailing of this column strip. That is the third column strips. Now let me go to the bottom, or the positive reinforcement detailing of the third column strips. Here the positive reinforcement, the maximum positive reinforcement is, it is around, how much is it? It is 940. It is 940. See the maximum. So I can take the maximum. That is 940. So diameter 16 with a spacing of 200. This is what? Diameter 16 with spacing of 200. Or I can use a diameter 12 with a spacing of what? 100. So diameter 12 with a spacing of 100 is provided throughout the uh, length of the column strips of this axis. Okay, now let me go to the fourth middle strip portion of this flat slab. So I can take this one, just this middle strip portion. Here, first I need to detail the negative reinforcement. So the negative reinforcement at this portion is, it is around 416. So 416, I can use diameter 12 with the spacing of what? 200. I can use 200. Here, that is diameter 16 at 300, or just I can take diameter 16 also. So diameter 16 with a spacing of how much? It is 300. So diameter 16 at 300 spacing. This one. The second column strip, this one. I mean the second supports of this middle strip. That is 460, which is the same. That is diameter 60 with a spacing of 300. Now the third support, which is also the same. 1, 2. The third support is which is around here. It is also the same. So I can the same reinforcement area, and this one is also the same reinforcement area. So throughout I can use the same negative reinforcement area. So that is diameter 60 with center to center 300, diameter 60 with center centers 300, 300, 300. So throughout. So now let me come back to the positive reinforcements, or the bottom reinforcement detailing works of the fourth metal strips. Okay. Now let me go to the CSI SAFE. So I can take the maximum of the positive reinforcement. That is 579. 579 is the maximum of the positive reinforcements of this middle strip. That is 579, which is 580. So 580. Diameter 12 with the spacing of what? 175. So diameter 12, 175. Now the spacing it is defined clearly here. So throughout, that is diameter 12 is 175, diameter 12 175, diameter 12 175, and diameter 12 175. Now I have finished detailing the bottom and top reinforcements works of this middle strip. So now let me go to here. This one is also similar because this portion is included under the middle strip portion of this one. So here I can use the same bottom reinforcement. The only difference is the length of the bar here because there is an offset here. So the portion from here up to here it is included as it is the middle strip. Okay, now let me go to the last column strip here. This is the last column strip. So now let me detailing the negative reinforcement first. This one is this 460. So 416 is it is diameter 12 with the spacing of 200, or diameter 16 with a spacing of how much? So I can take this negative reinforcement. The governing one is this support. This one. That is 2055. That is 2055. How much is it? Diameter 60 with a spacing of how much? It is 75. That is diameter 60 with a spacing of 75. It is provided here. Diameter 16 with 75. This also, this support also. Now let me check it. Here, it is almost 2244. That is 2244. So need diameter 60 with 75, the same spacing. Here is diameter 60 with 75 spacing. Just go down here, this support also. This one. I can take this support. That is 460. Or I can take this one. 2015. That is 2040. That is 2040. How much is diameter 60? 75, which is the same. Diameter 60, 75. So I can span up to this point. Diameter 60, 75. I can span up to this point because all those are included under the column strip. So this one also diameter 16 with a spacing of 75 because the same reinforcement. Now let me check it. That is the third. 1, 2, 3, 4. The fourth column. 2283. 2283. Diameter 16, that is 75, which is the same. Which is diameter 60, 75. And here diameter 60, 75 also. Here. That means this one, which is 22, 13, which is the same reinforcement area. Nearly they are the same. Here, this reinforcement area and this reinforcement area, they are the same. So I can use the same diameter of negative reinforcement with the same river spacing. Now the last support, this one, which is how much is it? It is 18, 14. That is 18, 14. Diameter 60 with a spacing of 100. Diameter, this one. Diameter 16 with a spacing of 100. This one. So I need to be economical because I need to take the negative reinforcement area at every support in order to be economic. If I take the maximum negative moment of the supports of the strips, I will not be economic. Okay, I have finished detailing the negative reinforcements of the last column strips. Now let me detailing the bottom reinforcements or the positive reinforcements of the last column strip. So I'll go to CSI SAFE. Here I can take the maximum positive reinforcement. Here 592 is the maximum one. Let me check it once. It is 592. 592. I think there may not be any other 500, 598. That is 600 nearly 635. So 635 is the maximum one. 635 is the maximum one. So I can use diameter 12 with a spacing of 175. So here diameter 12 175, like that is diameter 12 175, diameter 12 175 spacing as a positive reinforcement. Now let me go to the last column and strip, this column and strip here. So come back to CSI SAFE. Here the negative reinforcement is around here. It is 900, 900. It is 990. It is 990. 990. So diameter 16 with 200. Diameter 16 with 200. Sorry, just go back again. Diameter 16, 200. Diameter 16, it is 200. This one. So diameter 16, 200. And the middle support 1097. That is 1097. Diameter 16 with 175. This one is diameter 16 with 175. Now let me check once again this support. It is 760. 700. That is 800. So diameter 16 with a spacing of 250. So it is 250. Okay, now let me check the positive reinforcement. So I can take the maximum positive reinforcement area, that is 600, 651. So diameter 12 with a spacing of 150. Diameter 12 with a spacing of 150 is provided. This diameter 12, 150 spacing is provided. So I have finished detailing of the positive and negative reinforcements at the columns and at the middle strips of this flat slab along the y direction, or along the strip B. So this is for strip B, or strips located along the direction of y axis. So we can also detail the reinforcement works of this flat slab along x-axis, that is along the layer A. So the procedures are, it is similar to what we have done for the y-axis. So here, just this is for strips which are placed along in y direction, and in similar manner we can do also for strips that are placed along in x direction. So the main point is the proper extraction of the maximum and the minimum reinforcement area for a specified strips. Then we need to convert it to the specified diameter and the spacing of the bars. So here, just we can go to here now. Just we have already finished it, calculating and assigning the positive and negative reinforcements for the columns and the middle strips that are placed along in y direction. So let's check for the strips which are located on the x direction. So to do this, we can select this one, because strips that are placed along in x directions are designated by layer A. So here I can keep all the rest as it is, and per unit area, per unit weightage of the reinforcement can be displayed. Now click this one. So here it is converted. Now, so we can check also the maximum and the maximum positive and negative reinforcement area per meter weightage here, and then convert it to the specified diameter and spacing. And in similar manner for the middle strip here, this is the middle strip, and we can calculate the maximum reinforcement area for the positive and negative reinforcements for these middle strips, and then convert it to the diameter and spacing of reinforcement. And in similar way, we can also just you can take here the maximum value is the maximum value at the controlling point is displayed here. Even we can take from this. For instance, for example, at this point here, the reinforcement area is 460 per meter width. And here at the positive reinforcement area, the maximum positive reinforcement area at the midpoint of this span is 416.81 millimeters square per meter width, and similarly here. So what we take is for bottom reinforcement, that is the maximum one is this 476 here. So we can take 476 as bottom reinforcement for this middle strip, and we need to convert it to the specified diameter and spacing. And for this strip also, we need to take 730.36 millimeters square per meter width of positive reinforcement area, and we need to convert it to the specified rebar diameter and spacing. So when we come to also this one here, and in similar manner also for negative reinforcement, 460, 460, 460, and that is here, it is 833, and we need to convert it to the specified diameter and spacing of reinforcement for, and then apply for the whole negative reinforcements at the support zone. So this is, for the condition where we can here, just this is show the rebar intensity area per unit width for layer A. And if we click this one, so the total rebar area for the strip will be displayed. So in this case, there is no any change in the results, because unit width is similar to the strip of the defined width of the strip. So that is why I originally defined it as 1 meter width is straight. So now let me click apply here. It is 416 now. Yeah, 417. No change outward. So here the previous one is that is 416.8. So just come to here. That is no change outward. So 417. So that is why it is advantageous to define the width of the strip 1 meter. But the actual width of the strip must be the 25% of the shorter span, both on the right and on the left sides of the strip, the column strips. And for the middle strip, the rest one. So here the actual strip width must be defined properly, just like this. Here, for example, I have already defined it before. For this one, now let me come back to here. So this is, three, what is it is 7750 and this one is 6800. So which one is the shorter one? This one for this column strip. So 25% of 6800 becomes what? How much is it? How much is it? It becomes, so this is it is 1700. 1700. So 1700 multiplied with 2 is 3400. So 3400 will be the width of this column strip. So in tutorial part 24, I have already shown you how to define the width of the column strips and the middle strips. So just you can come back to that. Just you can go back to tutorial part 24 and you can check the way how to calculate the columns and the middle strips. And here the remaining part will be the middle strip, this one. And this one will be the middle strips, because here I need to define first the column strip here and the column strip here, and I need to calculate the width of the strip, the width of the strips. After that, the remaining portion will be considered as a middle strip. So in this way, the columns and the middle, the size of the middle strips and the column strips can be calculated. So now let me come back to CSI SAFE. So this way here, just I can apply the actual width here. So be taken that. So I need to lay the reinforcements for the calculated width of the strip, not for 1 meter. 1 meter is for the sake of calculating the reinforcement area and the spacing of the reinforcement. So having in mind the diameter and the spacing of the reinforcement, so we need to lay within the actual calculated width of the strip. So we should not use 1 meter for the arrangements of the reinforcement. So we need to take the actual strip width. Okay, here, so when I come back to also the third one, here show rebar number of bars of size. For example, I can select 16. That is the top bar is it is 16 and the bottom bar is it is 12. Now, sorry. So I can select it. So the top bar is it is 16. Most of the top bars are 16, and all of the bottom bars are it is 12 in diameter. So, and when we come to the spacing also, just okay, before that, now let me show you how to calculate the number of rebar per strip in this one. So the width of the strip is it is 1 meter. Then 3 diameter 16 rebar is required at the top, and similarly at the bottom And similarly at the bottom here, that is for diameter, 12 rebar is required. So this is for 1 meter width. So we need to change it to the actual width. So just calculating the number of bar in a specified strip is not that much relevant. So we need to take this option, this option, the first one, which provide the actual reinforcement area per width of the strip. And when we come to here also, just we can specify the diameter here. The top one is at 60 with a spacing of let's say 100, because diameter 60 with a spacing of 100 is it is a common most of the top bars are diameter 60 with a spacing of 100, and the bottom bars are diameter 12 with a spacing of what, which is also 100. So now apply here. If you see, just the design is okay, but extra bars are required here at this point and at this point. Almost the design is it is okay. So providing diameter 16 at a spacing of 100 millimeter at the top, and provide diameter 12 at a spacing of 100 as bottom reinforcement for the whole strips is adequate enough to withstand the superimposed coating. But here, as you remember before, here, diameter 16, diameter 20 rebar were used at all those portions, So here also, here. So this is, I think, the the best way when we use a uniform bottom reinforcement and a uniform top reinforcement. But this may not be economical, because at some location we were using diameter 16 at a spacing of 175 even. And we were using diameter 12 at a spacing of 175 and 150. So we may not be economical. So that is better if we calculate the amount of reinforcement for every strips. Okay, this is I think all about for the designing of a slab using a strip method. So now let me show you the designing of a strips using the finite element method. Just to do this, just go to here, and we need to select the finite element method here. So here we have 4 direction. We have 4 direction. That is, direction 1 indicates top rebar. Here in this direction, this is top. And here, this is suppose this is a section of the slab. And here, suppose this is X direction. So here we have a rebar here. So here, the direction of top rebar means this one. It's a reinforcement. And direction 1 bottom reinforcements means this one. That is the reinforcement which will be laid along the X direction. And direction to top reinforcement is this one. This one. And direction to bottom reinforcement is this one. So, using this designation of CSI SAFE, we can calculate the amount of reinforcement. Now let me just apply this one here. Here, sorry, I have already specified the spacing here, so I can make it now. Look, Here, this is you know we can extract the amount of reinforcement area per meter width is at every finite element. Here for this one, we can extra for this one, for this one, for this one. So, as the name indicates, finite element method, as you see here, every panel is divided into smaller elements. So those smaller elements, what we call it is finite elements. So for every finite elements, the reinforcement area is calculated by CSI SAFE. So we can extract here just by clicking here. When we put just this one, when we put here, it is almost zero because it is the middle strip. The reinforcement here, this is, direction to top. Now let me define for direction one top, apply. Direction one top. This is the negative reinforcement. This is the bottom reinforcement for the middle strips, and this is the top reinforcement uh, for the column strip here. So almost the results which is obtained from the finite element analysis is almost similar to the result obtained from the design strip method. So here, just okay, you can see this is almost zero, and when we come to here, the reinforcements are here displayed here, just like this here. You can see it. This is the negative reinforcement. That is top negative reinforcement. And here we don't have any top reinforcement here because it is a middle span. And here we have a top reinforcement because it is a column strips and it is needing negative reinforcement at the top. Here just you can see. So just I can extract here the maximum reinforcement here. So now let me first check for the strip method for layer A. That's for layer B. Sorry. For layer B here, that is 3137. 31. Just you can see here. Just you can read here. 3132. 3132, which is the maximum negative reinforcement here. Just use this is based on the finite element, based on the strip method. And when I use the finite element method, that is this one. That is the direction tool, which is a long way direction. Oh. And when I click here, just here, sorry. Yeah, it is almost, this one is, it is 3000 and the finite element output is, it is 2200. So, finite element method is more precise than that of the strip method. So, yeah, using the strip method is more the governing one, and we will be on the safe side. So this is all about for today's tutorials, which is focusing on the designing of the flat slabs of this journey. The story building using CSI SAFE 2021. And as per the Ethiopian Building Code of Standard and European Building Code of Standard. So if you like my video, don't forget sharing all my videos to your friends so that your friends will be getting more relevant tutorials which have been already prepared with reference to the detailed modeling, analysis, and designing of this theory, story building as per the Ethiopian Building Code of Standard and the European Building Code of Standard. So, if you are not a new member, don't forget subscribe my channel. If you subscribe my channel, you will be getting more relevant tutorials which have been prepared with reference to the civil engineering projects. So, if you are a new member for this channel, don't forget to subscribe my channel. If you subscribe my channel, you will be getting more relevant tutorials, which have already been prepared with reference to the structural modeling, analysis, and designing of any civil engineering projects. So if you wanted to just receive a notification during the uploading of my videos, just you can press the bell icon. So see you next time with a very interesting topic that will be focusing on the designing of punching for flat slab of this journey story building. Bye bye.